What I am here to talk about is the GreenDeal Data Space. I'm here working with my company, Bloodstone Consulting, and where we will act as the technical coordinator for, let's move to the next slide if you can. I'll be taking the role of technical coordinator in implementing the GreenDeal Data Space, which is one of the, I don't know, the number changes, but roughly 14 common European data spaces that the European Commission has decided to create. The GreenDeal Data Space is a challenge because it's not very precise. It's very broad. It covers many things. It's unclear what the focus is. So how will we make that practical? So this is a project overview. I hope you can read that from the distance. It's a 36-month project that will start in March. Over 40 partners, 16 million euros in total, of which 50% is co-funded by the Commission. The IDC, International Data Corporation, is the lead, and I'm acting as the technical work coordinator. There are partners like iSHARE, which we're very happy to have as a key technical and business partner for us, as well as a number of other technical partners. The key point about the GreenDeal Data Space is everybody here has read, I'm sure, many articles about Green Deal, the green transition, the green and digital transformation that the European Commission has discussed as being critical for Europe. So what is this really going to be? So in our case, because the subject is so broad and the impact is so vast, we're going to focus on some specific use cases. And we're going to be very focused on getting those use cases to work within the scope of our 3-year project. We will invite many other people to join us, other data providers, other data users. We want to create as open an ecosystem as possible, but fundamentally, it'll be me with the whip who will be saying these 10 use cases need to work. So I won't go into a lot of the detail, but I will talk about a few of them as we go along, but they do cover a wide range of activities. Forest transformation is a great example, and this is a situation where the European Commission has actually, the European Union has actually passed laws about forest management, forest conservation, reforestation, and they're very interested to influence the way that private forest holders manage their forest holdings in a way that is maximizing their value and at the same time maximizing the benefit to the environment. So, there may be good ways of doing it, or they could hold it for too long and it'll burn down in a forest fire or be eaten up by pests. So there are some mutually beneficial situations, and the purpose of the use case is to help private forest holders maximize their return and improve the environmental sustainability. This is a very quick overview of the architecture. At the top, you see the 𝐶EIGH users. These people are outside of 𝐶EIGH, the data space. They may connect, they may access this information through connectors. Those are those blue things on the far right. The 𝐶EIGH data space is the octagon, the green octagon in the middle. And of interest at this point is the idea that there will be a federated AAI, a common authentication system across the entire data space. There will be some sort of catalog and marketplace. Some can argue about this, but in fact, there are questions about how to handle it, and there are experience in the research environment, and there is a lot of research data involved where having a catalog will help. These little gizmos, here, these are access control mechanisms. And right now, that's something that we're focusing on as a way to ensure that there's consistent policy implementation, policy evaluation, and execution for access and use control of data, regardless of where the data is coming from or where it's going to inside the data space. Down below, we have 𝐶EIGH providers, which could number into the thousands. They will certainly number in the hundreds within the scope of our project. They will be providing and exposing resources to the 𝐶EIGH data space and data users. They could be using connectors. They could be using their own API data services and saying, I don't give a damn about your connectors and I'm not going to use it. We want to use, you can access our API data services, but we're not going to play any games with your technology. There are data lakes coming from digital twins. There are other data spaces, energy, agriculture, smart cities. There's the European Open Science Cloud. There's a bunch of ESFRIs, European, I don't even know what it stands for. They're research infrastructures that focus on very specific areas of interest to the environment. And then, of course, Destination Earth, blue clouds, and digital twins that are out there. Okay, expanding the architecture a little bit, lots of moving parts. The key point here is the mandatory services for 𝐶 use cases. So we're going to ask those 10 use cases from the get-go to use federated AI, use the same observability system, use the same registry systems, and have this common access and use policy evaluation. There are a lot of other choices: PIDs, Confluence, monitoring help desk, order management, secure, all the things that are marked in green there, catalog and marketplace. These are more optional at the outset. Our objective is to create a common underpinning for all these use cases so that once they adopt them, they will be more interoperable. A key issue is creating shared value from data. So if I bring data from provider A, B, and C, data from 3 providers, and I combine it and create some new data, who benefits from that? If it's public data, nobody really cares. They just want credit. They want you to record the citation. But if it's data that was proprietary, that was contributed with a specific purpose in mind and with a narrow sort of ring fence around what you can do with the data, you have to manage what that resulting product is. And that's why we want to be able to limit visibility, access, and use to these derivative products in a way that the use case participants, the people who contributed to the data or participated in some way, gain priority access to these shared results. Participants from outside the use case might pay, or they might get delayed access, but there'd be some mechanism that would translate or generate a value for the original participants and create perhaps economic value in the later participants. That's kind of the Kickstarter model, if you're familiar with that. So this also supports control over competitor access, and it also supports circular economy. So we can ring fence transactions, much like what we saw just a moment ago, where there's a series of essentially EDI transactions being ring fenced, and not everybody can see everything because they're not supposed to. 2 minutes left. Okay. Should be enough. So I'm not going to go into detail. These slides will be available, but there's going to be effort needed to make services work across different domains. So this is data federation. I can talk about this ad nauseum if you'd like later, but we won't discuss it now. But a list of key challenges that we have. One is we're expected to adopt Simple, the smart middleware platform from the European Commission, which I've had the pleasure of reading their architecture, and I think that's going to be a lot of fun. That's a joke. Their self-descriptions use DCAT. That may not be fit for purpose. They have service descriptions that need to be followed. There's an authentication issue, which we don't quite adapt to. It needs to be a little more robust. We need to have a good model of identities, the core of identities across different research, the research domain and the industry domain. Good structures for credentials, not only the identities, but also the credentials, the things in the wallet, the credit cards, the driver's license, all that kind of stuff that goes with your identity. Good data models and interoperability. How do we make that work? Very hard problem, not solved, but it's something we'll tackle on a use case basis. Federated search and discovery. How do we find the right kind of data amongst 1,000 data providers, each of whom may have 20 petabytes of data? Very difficult problem. We cannot simply spread this out, I think, to a bunch of connectors, because the search will simply never finish. How do we package raw data sources in a way that can be used inside a structured data environment? This is that outside data coming in via API data services. And then how do we integrate data? Lots of ideas, but not ones that work well in production. And with that, I might be on time.
Perfectly.
Okay. Thank you.